All right, today we are pulling back the curtain on our digital world. We're going to meet the masterminds who actually build the very infrastructure that keeps all of us connected. These are the architects of our digital lives.
I mean, really think about that for a second. From streaming your favorite show to making an online purchase, all the way to the incredibly complex systems that run our hospitals and power grids, literally none of it would be possible without these hidden architects. They are, without a doubt, the backbone of our modern world.
And you know, this is a really high-stakes world. We all remember that big Facebook outage, right? It showed us just how fragile all this connectivity can be. So when everything suddenly goes dark, who's the one that answers the call? Well, the answer is network engineers. These are the pros who design, build, and, yes, troubleshoot the absolutely massive, complex systems that make up the internet and all the private networks all over the globe. So what does that actually mean? Essentially, if data is moving from point A to point B, you can bet a network engineer figured out the very best way to make that journey happen. They're working with everything from a local area network, or LAN, in a single office, to a wide area network, a WAN, that literally spans continents.
Now, it's really easy to get a network engineer confused with a network administrator, but the analogy here on the slide makes it super simple. Think of the engineer as the architect who designs a city's entire road system. The administrator, on the other hand, is like the city manager, who makes sure the traffic lights are working and the potholes get filled, day to day.
Okay, so how do they actually build these digital highways? Well, engineers rely on a very specific set of tools and foundational concepts. Let's take a look inside their toolkit. Before you can even think about building a network, you have to understand the rules of communication. And these conceptual models, they provide a standardized framework, a blueprint really, that makes sure that devices made by all these different companies can all speak the same language. The two most important models you'll hear about are the OSI model and the TCP/IP model. So the OSI model is this 7-layer theoretical framework that is absolutely fantastic for learning and troubleshooting. But the TCP/IP model, that's the more streamlined, practical set of protocols that the actual internet runs on today. It's the application. And this slide uses a great analogy to explain the OSI model, a postal system. So think of layer 1, the physical layer, as the actual trucks and roads. Layer 3, the network layer, that's like the GPS using an IP address to find the best route. And layer 4, the transport layer, that's your delivery confirmation, making sure the package got there safely. See, each layer has a very specific job, and they all work together to get your data from point A to B. But of course, you also need the physical gear. Routers are kind of like the major highway interchanges that connect different cities, or networks. Switches, then, are the local roads connecting all the houses in one neighborhood. And firewalls? They're the security guards at the entrance to the city, checking IDs and deciding who gets in and who doesn't. So, how do those routers even know where to send all that traffic? Well, with static routing, an engineer literally manually programs a fixed route. It's like telling your GPS to always take a specific highway, no matter what. With dynamic routing, though, automated protocols are constantly talking to each other, finding the fastest path in real time, just like a modern navigation app rerouting you around a traffic jam.
Okay, so let's see how this all comes together. How do engineers use all these tools and concepts to build and, just as importantly, protect the networks that we all rely on every single day?
A typical day is, well, it's a mix of strategic planning and rapid response problem solving. One moment they might be designing a brand new scalable network for a growing company. The next, they're in the trenches troubleshooting a critical outage to get services back online fast. And more, they're writing scripts and languages like Python to automate routine tasks, which makes the whole network smarter and way more efficient. Now, this number on the slide is fascinating. A Cisco study found that a staggering 85% of network outages are caused by human error. But listen, this isn't about people being careless. It's a reflection of the incredible complexity of modern networks. With thousands of lines of configuration done by hand, one tiny typo can have a massive, cascading effect. It really just highlights why having skilled, super detail-oriented engineers is so absolutely crucial.
And the field is also incredibly broad, which allows people to specialize. You have security engineers who focus on defending against cyber attacks. Cloud engineers live and breathe in environments like AWS and Azure. And wireless engineers, well, they're the experts making sure our Wi-Fi is fast and reliable. Each one of these roles is a critical piece of a much larger puzzle.
But no matter what you specialize in, security is everything. And the firewall is the absolute cornerstone of network security. It acts as a digital gatekeeper,
inspecting every single packet of data and deciding whether to let it pass or block it based on a set of security rules. It is the network's essential first line of defense.
And, managing these complex firewalls is a full-time job in itself. That's exactly why for mission-critical systems, a lot of organizations rely on dedicated support centers. They provide that expert configuration, monitoring, and incident response needed to make sure their digital fortress stays secure. But as we all know, technology never ever stands still. The networks of today look vastly different from the ones just a decade ago, and so the role of the network engineer is constantly evolving to keep up.
We're seeing this massive shift right now. The move to the cloud is in full swing, and automation isn't a luxury anymore, it's a necessity. Very soon, we'll see AI that can proactively predict and even fix network issues before we notice. And new architectures like SASE, that stands for Secure Access Service Edge, are changing everything, merging networking and security into a single, cloud-based service.
So here's the crucial point, the main takeaway from all this. For a network engineer, the learning never stops. The technology evolves so quickly that a commitment to continuous education, earning new certifications, staying on top of trends, it isn't just a good idea, it is absolutely essential for survival in this field.
Which really leaves us with a fascinating question for the future. As networks get smarter and more self-sufficient thanks to AI and automation, what becomes the most important human element? What skills, like strategic thinking or creativity or complex problem solving, what will define the next generation of these network architects?